Welcome back. Today, I'm going to be going over 4 multiple choice questions and 3 free response questions related to higher order derivatives. All right, so the first one says, let f of x equal to x cubed minus 4x squared plus 2x. What is the second derivative of f of x? Okay, so what I'm basically going to do for this one is I'm first just going to find the first derivative of f of x, and then I'm going to find the derivative of that derivative, and that's going to be my second derivative. So first, in order to find the second derivative, I first need to find the first derivative. So my first derivative, just using the power rule, would be 3x squared minus 8x plus 2. Okay, then the derivative of that derivative, also using the power rule again, we get 6x minus 8. And recall the 2 at the end, that since that's a constant, that just, because the derivative of that is just 0, so that just disappears. And so our final answer would be A, 6x minus 8. All right, so here's another one. This one asks, if y is equal to ln of 2x plus 1, what is the second derivative? This is just different notation to say the second derivative. So once again, in order to find the second derivative, I first need to find the first derivative. All right, so in order to do that, I'm going to need to use the chain rule. This one isn't as simple as the power rule. So I know in the first example, I kind of just glossed through because power rule is the very, very basics of derivatives. Chain rule is a little bit more tricky. So I am going to go through in a bit more detail here how we would find the derivative, but also the second derivative as well. All right, so first for chain rule, basically chain rule states that we have essentially an inner function and an outer function. So y is equal to f of g of x. And the derivative when we have a function of a function is the derivative of f of g of x times the derivative of g of x, okay? So in this case specifically, notice that we have ln as our outer function, so f would be ln of x, and then g, our inner function in this case, is just this linear, it's this 2x plus 1. Okay, so what is the derivative of each? What's the derivative of ln x? Well, recall that derivative of ln x is 1 over x. And then also recall, so derivative for g would just be 2 in this case, just using power rule. Okay, so now let's incorporate that into our equation. So we're going to end up with the first derivative being 1 over 2x plus 1, and then times the derivative of 2x plus 1, so times g prime, which is 2. So I'll just put a 2 on top there. And there we go. So that's my first derivative. Now, in order to get the second derivative, I need to take the derivative of that number. So how do I take the derivative of that? Well, now we have a quotient. So I'm going to be using the quotient rule to do this one. Or actually, you know what? I could even rewrite this. I'm just noticing. In the numerator, we just have a 2 actually. So I've changed my mind. I'm just going to say that this is the same as 2 times 2x plus 1 to the power of negative 1. And I'm going to use the chain rule once again, okay? This time with our inner function being 2x plus 1, and my outer function being negative 1. So I'm going to put negative 1 out in front, so we're going to get negative 1 times 2, which will be negative 2, times whatever's in there, 2x plus 1, and then we'll subtract that. So we'll subtract 1 from our exponent, so we'll get negative 2 there. And then what's the derivative of 2x plus 1? Well, still 2. So I'm going to multiply by 2 again. And then we're going to end up with negative 4 over 2x plus 1 squared. And that is the equivalent of b. And so b is the correct answer for this one. All right, this next one says the position of a particle is given by this function. At what time is the acceleration 0? Okay, so recall that the acceleration is the same as the second derivative of the position, right? So the first derivative of position would give us velocity, and then the derivative of velocity, or in other words, the second derivative of position, is going to give us the acceleration. So first, I need to find the first derivative, which is equal to the velocity, and that's going to be equal to 3t squared minus 12t plus 9. And then for the second derivative of the position, that's going to be the same as the acceleration, which is going to be 6t minus 12. And there we go. We did it. Now I need to set that acceleration to 0. So 0 is equal to 6t minus 12, meaning 6t is equal to 12, meaning t is equal to 2. So our answer is B here, once again, actually, because we ended up getting that the time is equal to 2 during the time that the acceleration is 0. So there we go. All right, and here's our last of the multiple choice. After this, we're going to get into 3 long answer questions, 3 just free response questions, so to speak. If f of x is equal to sine of 3x, what is the fourth derivative of x? Okay, well, recall that sine goes in a cycle, right? It goes sine, then the derivative of sine is cosine, then negative sine, then negative cosine, and then the cycle just repeats all over again. Sine, blah, blah, cosine, negative cos, right? It keeps doing that. Then also recall that if we have 3x, every time that we take the derivative, we have to chain that. We have to multiply it by the derivative of 3x, which the derivative of 3x is just 3, right? So if I take the first derivative, I'm going to get cosine of 3x and then times 3. If I do it again, I'm going to get, well, what's after cos in the cycle? Well, that would be negative sine, so negative sine of 3x, and then times 3 that we have here, and then times another 3, because I take the derivative again. And then I'm going to do the third derivative. So that is going to be, well, what's next in the cycle? Negative cosine. So negative cosine 3x times 3 that are already there, and then times another 3 because we take the derivative of this again. And then what about, at long last, the one we're actually looking for? Well, what comes next in the cycle? Actually, sine is back. So it's going to be sine of 3x once again, and then times 3 times another 3 because we're taking the derivative of this once again, the 3x. So if we neaten that up, we get 3 to the power 4, which is 81. So the fourth derivative is 81 sine 3x, and that'd be A. And there we go.